we want to solve for x in these equations. The first question is 32 raised to the power x equals to 0.25. As we can see, we've been doing a lot of indicial equation. We've been doing a lot of that, but we haven't done something like the one that has the decimals. And we're going to look into that today. The first thing we have to do is to convert that decimal back into fraction. So in doing that, and the essence of doing that is because I know that I have 32 raised to the power x, which can be turned into 2 raised to the power 5. And so in that way, I will have this 32 raised to the power x, which now equals to, I turn this one back into fraction, 25 over 100. So if I do that, that means I'm having 32 raised to the power x can also be 25 here 1 and 25 in 100 to give me 4. To make it easier for us, we're going to have 32 raised to the power x will now be 4 raised to the power minus 1 or 2 raised to the power minus 2, depending on how you want to write it. But let's go into 4 raised to the power minus 1, of which we all know the law that says that a raised to the power minus 1 is the same as 1 over a. So in this case, I'll turn this one into 2 raised to the power 5, everything into x. We now equals to, this turns to 2 raised to the power 2 into bracket minus 1. And also, we know the rule that say that a raised to the power m into bracket n, we give a raised to the power m times n. So the same thing I'm going to do here. So this one will be 2 raised to the power 5x. I'm multiplying them out now. We now equals to 2 raised to the power minus 2. Because they have the same base, the 2 cancels the other 2. So I'm having 5x equals to minus 2. Yes, that is acceptable. You can drop that down because they have the same base. So therefore, I'm looking for the value of x. So, and I'm having 5x. So if I divide both sides by 5, divide this by 5. So I'm having 5x divided by 5 equals to minus 2 over 5. 5 cancel 5. Therefore, my x equals to minus 2 over 5. And that is the answer for that. So the next one we are going to look at is this one that says 0.25 into x raised to the power x minus 1 equals to 32. So it looked like it's the same with the first one we did, but we're still going to go into the same path. So 0.25 can be turned into fraction to become 25 over 100 all raised to the power x minus 1 equals to 32. Without taking our time, 25 in 25, 1, 25 in 100 will give 4. So I have 1 over 4 into x minus 1. I'm turning this one straight away to 2 raised to the power 5. And in that case, 1 over 4 can be turned into 2 raised to the power minus 2. 2 raised to the power minus, because we're going to have 4 raised to the power minus 1. Then we're turning everything into 2 base, so it will now be 2 raised to the power minus 2. I will bracket all this out, x minus 1 equals to 2 raised to the power 5. So that is what we did here. I turned this one back into 2, like 1 over 2 raised to the power 2. Then when it's going upward, it's going to become 2 raised to the power minus 2. So in that way, I can multiply this out based on the law that says a raised to the power m into bracket n to give a raised to the power m times n. So this becomes 2 raised to the power minus 2x plus 2. This will equal to 2 raised to the power 5. Because they have the same base, so the 2 goes up, the 2 goes over, the 2 goes over. So I'm going to have minus 2x plus 2 equals to 5. In that way, I will collect the like term, and when I'm collecting the like term, it shows that I can take this plus 2 to the other side. And when I'm taking plus 2 to the other side, it becomes minus 2. So minus 2x will equal to 5 minus 2. It is also easy for you to say minus 2 to both sides. Just say minus 2, and then plus 2 minus 2 will give you 0. So it's still the same thing. So we need, this will now be minus 2x equals to 3. We need the value of x, not 2x. So we're going to divide both sides by 2. So I have minus 2x divided by 2 equals to 3 divided by 2. So I have minus x equals to 3 over 2. But we are looking for the value of x, not minus x. What do? You multiply both sides by minus 1. And when you do that, you have minus 1 times minus x equals to minus 1 times 3 over 2. So minus times minus become plus, invisible one. So I have my x equals to minus 3 over 2. So that is the answer to that one too. So we can manage to do the third one here. Let's fix the third one here. So we can fix the third one here. And that one is 4 raised to the power x plus 1 equals to 8 raised to the power x plus 2. What do? We turn these bases into 2 raised to the power something. So 4 will be 2 raised to the power 2. I'll bracket them out. Will now be 8 will be 2 raised to the power 3. I'll bracket them out. X plus 2. So turning 4 to 2 raised to the power 2 shouldn't be any issue, because we know that 4 will give us 2 times 2. That means that 2 raised to the power 2 means 2 in 2 places. 2 raised to the power 3 means 2 in 3 places. That's the meaning of raised to the power in 2 places or in 3 places. So if I multiply this out, I will have 2 into raised to the power 2x plus 2 will now equals to 2 raised to the power 3x plus 6. So in that way, this is out, this is out. So I'm having 2x plus 2 equals to 3x plus 6. And if I collect the like term, I'm going to have 2x, this come to this side, minus 3x equal to 6, and this go to the other side, minus 2. So I'm having minus x equals to 4. The same thing here is that I'm having minus 4 equals to 4. What do? We multiply both sides by minus 1. And if we do that, my x will now equals to minus 4. So this is the answer to this one too. So the fourth one is 2 times 4 raised to the power x equal to 16 raised to the power x divided by 8 raised to the power 1 minus x. We're going to look at that quickly and see what we're going to have on that. So if I have, this is the fourth one, if I have 2 times 4 raised to the power x minus 3 equals to 16x divided by 8 raised to the power 1 minus x. So what I will do is to turn this to 2 raised to the power something, because we already have this one as 2 raised to the power 1. This will be 2 raised to the power 1 times 2 raised to the power 2. I'm bracketing it out, x minus 3 will equals to 16 can be written as 2 raised to the power 4. I'm bracketing out into bracket x. Then 8 can be written as 2 raised to the power 3. I'm bracketing everything out, 1 minus x. If that is good, so we can go ahead with this one. Also, there's something we have to know about the laws of indices, that if you have a raised to the power m times a raised to the power n will give us a raised to the power m plus n. And also if you have a raised to the power m divided by a raised to the power n to give us a raised to the power m minus n. So the same thing I'm going to apply here. And what am I applying is that I'll have 2 raised to the power 1 times, I'm going to take this out real quick, 2 raised to the power 2x minus 6. I'm pretty sure we're following. We now equals to 2 raised to the power 4x. Because of this, let's continue. Divided by 2 raised to the power 3 minus 3x. So if we have that, we can continue solving. And because of this law that says a raised to the power m times a raised to the power n to give a raised to the power m plus 1. So this one, they have the same base, becomes 2 raised to the power 1 plus 2x minus 6. Fine. Equals to, then I turn this one, because of this law also, into 2 raised to the power 4x, and this one become minus 3 minus 3x. So we have 2 raised to the power 1 plus 2x minus 6 will now equals to 2 raised to the power 4x minus 3 plus 3x. Because we have the same base, so this cancels out this. So we have 1 plus 2x minus 6 equal to 4x minus 3 plus 3x. In that way, we have 1 plus 2x minus 6 equals to, this will equal to 7x minus 3. If I'm on the same page as you are, we can collect the like term, and when we do that, we're going to have 1 minus 6. Because they are on the same side, they retain their signs. So I have 1 minus 6, but because this is coming from the other side, so the minus sign becomes plus if you come to this sign. So I'm having plus 3, which now equals to 7x. Then I'm bringing this from the left hand side, which is plus 2x, to the other side will become minus 2x. So solving this, 1 minus 6 we give minus 5, plus 2 we give minus 2. Yeah, we have said something about this, is that 1 minus 6 is that I have $1 and I borrowed $6. So if I'm able to pay back $1 out of the $6, that means I will still need to pay the person back with $5. So that's why 1 minus 6 is minus 5. Then plus 3, we give plus 3, minus 5 means I still borrow $5. Then I have $3. If I pay $3 back from that $5, I will have $2 to pay the person back. So I have minus 2 will equals to 5x. The same method of explanation here. So because we have, I can just flip this over. It doesn't really matter if I write it in this way. 5x equals to minus 2 is the same thing. So we are asked to find the value of x, but we have 5x, so we can divide both sides by 5 equals to minus 2 over 5. So in that way, 5 cancel 5, I have my x equals to minus 2 over 5. And that will be the answer to that one too. So this means that we have all these 4 equations, the 4 questions solved. And thank you for watching my videos. I'll see you in the next one.